Today's experiment, Experiment 9, will be about reaction mechanics. First, we will work on reactivity in single replacement reactions, in which we will be creating an activity series. Then we will look at some things that affect reaction rates, where we will look at both the effect of catalyst and of temperature on the rate of a reaction. And finally, we will look at an equilibrium reaction, where we will focus on the effect of concentration of reactants and products and the effect of temperature on the equilibrium. First, we will be looking at single replacement reactions, and we will figure out how to create an activity series. An activity series lists the metals or nonmetals in order of their reactivity in a single replacement reaction. These reactivity series can be listed from top to bottom or left to right. In the single replacement reaction shown below, you can see that element A replaces compound BX and forms the new compound AX and the new element B. But recall that just because we can write a reaction doesn't mean it actually occurs. If we have an activity series, we can use it to compare the two elements and decide whether a reaction does or does not occur. Here we see the two elements we are comparing are A and B. A will replace B if A is above B on the activity series, which we see up here and here. A is above B. That tells us that this reaction occurs. In this reaction, our two elements are C and B. To see if this reaction actually occurs, we check to see if the element on the reactant side is greater than the element on the product side. And here we see that is not true up above, so this reaction does not occur. In today's lab, you will be developing an activity series based on a series of reactions. For example, in this reaction, if the reaction of A with BX gives us a new compound, whereas in this reaction, no new compound CX or element B forms, so the reaction does not occur. This tells us that element C is less active than B, or, to be consistent, that B is more active than C. We can put these together, A greater than B and B greater than C, where we can see that A is above B and B is above C, and all together we find A is above B, which is above C. That is our activity series. Okay, so now, how do you know if a reaction actually occurs? Well, you already know there are 4 signs of a chemical reaction. Let's list those. Number 1, gas bubbles form. Number 2, a solid precipitate forms. Number 3, there is a color change. And number 4, heat or light is given off. Let's look at the following 2 examples. We'll look at rubidium reacting with water and cesium reacting with water. Let's watch the video.
That was rubidium. Let's see that again.
Do you think that a reaction occurred? Well, we certainly saw heat or light was given off, and you may have seen some gas bubble formation. This shows us that our elements, rubidium and hydrogen, rubidium is more reactive than hydrogen. Let's continue the video.
And now cesium.
Hopefully you can see that cesium and hydrogen, we did have a reaction gas bubbles formed, and heat or light was given off, and that tells us that cesium is more reactive than hydrogen. But how do we compare the rubidium and the cesium?